All right, yeah, welcome back again. We are continuing, and we want to look at the next supervised learning algorithm called decision tree. Decision tree, like I explained before, is typically binary tree structure. Uh, each node will only have two possibilities. It's basically an if-else structure that is continuous in nature. The algorithm works by recursively splitting the data into subsets based on the most significant feature at each node of the tree. Down the line, then predict the output, then you plot the tree. All right, so we're going to see how this is applied practically in R. So let's go to the R session. I'm going to first load our libraries. Load the library first. I'm going to load caret for classification and regression. Then R part, this R part is for the decision tree. Then this one to plot the tree, all right, itself, for the plotting. So let's load this. Then we are actually running our diabetes. Okay, so you see this usual summary. Then we will meet data with glimpse. Okay, so just you can see as usual. So this is a common thing we have done so far. So let's split our data set. We are going to use a create partition this time. So we can also use the other part we have used before, the other method, which is a split. So anyone that is okay, just 70 to 30%, you can see. So create partitions 30%, split for training data, testing data. All right, so then we train the model. Let's call it DT model, decision tree model. Then R part from this R part here for library, so we call it R part. Then that is function for decision tree. Then our target variable is diabetes. Then we want all the remaining data to be included. So we are training because our training data will be supplied here. Then our method is called class. So we run this line of code. All right, so that is run. Then we can now plot. We can plot the tree and see how the tree look like. We have trained the model already. So let us plot the tree and see how they look like. So just click on plot. How does plot? We pass our model. We are plot. We pass it in extra equals to 101. So under equal to true, so that it will be under each of them falling leaves of the true. We want to see the leaf falling, and at the same time, that's also give us the percentage of each of the three column variables. Let's run this. So this is the tree. All right, this is a tree. You can save this tree actually as a can export as PDF actually. As PDF. All right. You click on export it as PDF. Right. Export as PDF. So you can see the tree, your PDF file. Let's go to PDF. Let's go to PDF. You can see the tree. This is our this is a tree. All right. So you can zoom it bigger, so you can see, look at it. So from here, start from here, yes, no, goes down, goes down, goes down, it goes down. That's how it works. So that is decision tree. So let's continue. Let's make a prediction now. Make prediction. Okay, we have to predict our model. Our model use our test data to see the result. So we run this line of code. Then we evaluate the performance by putting configuration matrix. So just because I factored this particular one because of the error that was given before, because it was not based on factor before. I factor it so that in case you only give just make sure that it is factor here, so that sometimes it gives error. Decision tree usually do that, and add-on forest, so you can just factor the target variable so that it can be a factor variable automatically. So just run this line, create function matrix, then you can print our function matrix out. All right, so let's see the accuracy. We got 77.78, that's 77.78%. Right, so that's what we got. So that's our accuracy. You can see. So that is decision tree. Our accuracy is not that too much, not that too high, 77. But I think it can be improved upon. can be proof upon if you maybe only increase the number of the tree, maybe here under the training section here, you make the tree more where's the you can see pass more parameter here. Pass parameter there. So before we plot, so that is that for your tree. It's not that too complex. It's very simple, very straightforward. So you can get your accuracy and you can plot your tree if you need the tree. You can also plot scatter plot if you want to plot scatter plot, which I have shown several times. So I don't need to repeat that here again. So I'll see you in the next section. Thank you so much.